In this question, you have to be able to convert a denary number, which is the same as a decimal number, into hexadecimal. So the difference is denary can have digits from 0 up to 9, but hexadecimal you can have 0 to 9, but also have A, B, C, D, E, or F. So there's 10 possible digits you can have in a denary number, but there's 16 possible digits that you can have in a hexadecimal number. So let's start by converting from denary into binary and then from binary into hexadecimal. It's possible to do it in one step, but the maths is harder and you're not allowed a calculator in this exam, so it's much easier to do it from denary to binary and then from binary into hexadecimal. Okay, so let's convert from 125 into binary. I'd start by writing down your number on the right hand side and then keep dividing by 2 until you get down to 0. So a half of 125 is 62 and a half, but we'll ignore the half and just write down 62. So we say a half of 125 is 62 with 1 left over. I'll write the 1 up here. We keep on doing the same until we get to 0. So 61, half of that is, 62, half of that is 31 with nothing left over because 31 goes exactly into 62. Keep on doing the same, half of 31 is 15. Sorry, my computer sometimes freezes. Half of 31 is 15 with 1 left over. Half of 15 is 7 with 1 left over. Half of 7 is 3 with 1 left over. We keep on halving, so half of 3 is 1 with 1 left over. And half of 1 is 0 with 1 left over. And you could keep on going. Half of 0 is 0 and half of 0 is 0, but we'll stop as soon as we get to 0. Okay, so if the question was show the binary representation of 125, that would be your answer, but we need to go from this now to hexadecimal. So we've got one of the 2 marks so far. To convert to hexadecimal, we need to split it up into 4-bit sections, or 4-bit sections are called nibbles. We'll start from the right and go 1, 2, 3, 4. So this is going to be one of our nibbles. And then we've got 3 bits left, and there's a space on the left, and I'm going to put a 0 in there. Remember, if you put a 0 on the left of a binary number, it doesn't change it, but if you put a 0 on the right of a binary number, it does change it, which is why we had to start counting our 1, 2, 3, 4 bits for our nibbles from the right, rather than counting from the left. Okay, so we've got our 4-bit sections. We need to convert each of them into decimal. So 0, 1, 1, 1, that's this nibble here. Remember, the first bit is worth 1, and each one is worth twice as much. So 1, 2, 4, 8. And we add up the numbers with 1s on top. So 1 plus 2 plus 4 is 7. Same here, 1, 1, 0, 1. 1, 1, 0, 1. So that would be 1 plus 4 plus 8 equals 13. Okay, we're very nearly there. Now that we've got the value of both of these nibbles, we just need to write them in hexadecimal. So 7 is less than 10, so we can just write it down as it is. But 13 is more than 10, which means that we have to use the letters. So A would be 10, B would be 11, C would be 12, D we can use to represent 13. And if we wanted to carry on, E would be 14 and F would be 15. So the answer, what is the hexadecimal representation of the denary number 125? Your answer is 7D. You'd get 1 mark for converting it to binary and the second mark for converting that into hexadecimal. Or if you just get the right answer, you'd get 2 marks as long as you could show some sort of working out that got you there.